Hi everyone. So after the first year course being completed successfully, you are now moving to semester 3. So I am handling data structures and algorithms theory. Lab will be handled along with the Professor Chandrasekhar. So this lecture is recorded for theory course. So if you just recall what are the programs that you have written in the first year C programming lab, you might have used C programming data types like integer, float, double, etc. What I want to emphasize is the data structures that you have used, or data types, int, float, double, char, etc. So these are the data types which cannot be divided further. But if you have, say, keywords like struct, union, then this structure can have multiple number of data types inside it. Even structure can have another structure inside. So I am not sure how much you have done using structures, union, etc. But this will be required for, structure is required for data structure lab. Even in theory also, when you study the algorithm, you have the induction of structure. You should have the induction of structure. So what is a program about? So if you just recall the C programming lab, any program, it's about some input being given, then you have the program in C that converts the input to an output. So in this similar way, what you have is an algorithm. Algorithm is independent of any programming language. This algorithm. Algorithm has or requires some input data. And given this input data, it produces some output data. So if you look at any of the C programming lab exercise that you have done, this property will be there. Even so, for example, I will give one example which you have done in your lab is, suppose you have the input like 5, 0, 02, 03, 04, 31, 12, 42. You remember this lab experiment? This was like given a graph and you have to print the graph as a adjacency list. Like for every vertex, all its out neighbors should be listed in sorted order. Like here it's sorted, but after 0, 3 should not come, it should be 1, then it should be 2, then it should be 3, it should be 4. So the expected output is maybe. So for 0, the expected row, it will be $2, $3, $4. For 1, it is $2. Then this for 0, this for 1. For 2, there is no out neighbors, like 2 does not, there is no edge which start with vertex number 2. So we have 1, but there is no 2. Then for 3, it is $1. 4, it is $2. So here this first row denotes there are edges in the graph which are 0, 2, 0, 3, 0, 4. And also in the graph there is edge 1, 2. There is no edge which source vertex as 2. There is edge 3, 1. There is a edge 4, 2. Then you might have written some algorithm, but focus of this course, which is little more advanced, is like how much time the program that you have written will take. Or in this course, it will be independent of the programming language, so you will be using algorithm. You write some algorithm and find how much time that it will take, how much space it will take. For example, if you have stored this as a two-dimensional matrix, like say as a matrix with 5 rows and 5 columns. 5 rows and 5 columns. The amount of space it will be taking is 5 into 5, like that much entry. But here the number of entries is very limited. So this has some advantage in using space, like it uses very less space. Maybe the space or the way you store may help in writing better algorithms. So this is one example from your first year C programming. I just try to connect your first programming C lab to this data structure course. Here the theory course will be independent of the programming language. Even though you are implementing the lab in C, we will be using algorithms. Now how it can be different from or how it can be independent from a programming language, that I will explain. So maybe I will erase this. So I will write a pseudo code here, just so you will get an idea about what is pseudo code. Number of elements in here, then so here the pseudo code is written with function name, what is the input, what are the inputs and what is the output. So the inputs are a array A, it stores integer values. Another input is, this is the first input A, and the second input is number of elements in that array. Here we are not worried about specifying A as int A, N as int N, and nothing like that, but also output is maximum value in array A. That output value will be returned, will be available in max, say variable. So how you will do in a pseudo code is like, you are assuming array being accessed from 0th index. So the array index will be from 0 to n minus 1. So you have max assigned to A of 0, then for I equal to 1 to n minus 1, do if a of I greater than max then max assigned to a of I then end 4. If you look at this pseudo code, it's easy to read, like this is a for loop. Maybe I will make it a bit more clear. This is a for loop which iterates from I equal to 1 to n minus 1. Then there is a n4 here. This may not be present in any programming language, but just to identify that the for loop ends here, this notation is very good. Similarly, if this statement is there, which may be similar to C language statement. Also for assignment, I have used colon equal to. So what this does? So initially, if you have a array, suppose the array is like yes, so the index is from 0, 1, 2, 3, 4. So this first statement will assign max as 10. Then it will keep on iterating. Whenever an array element is greater than max, then max assigned to AI. So here max will be modified. It will be modified from 10 to 20. Here it will be modified from 20 to 30. So finally, once you have this n4, you return max. So and you close the function declaration. So there is no semicolon after statement. Nothing is required. Should be understandable. So now coming to just to introduce running time, how many times this statement will be executed? Assume this is like taking say C1 amount of time, where C1 is some time. So it takes C1 here. Then suppose this is like a statement, how many times it will be executed is n times, not n minus 1. I will come to that later. So this can be taken as C2 into n. What about this statement? This will be n minus 1. So you can take it like C3 into n minus 1. What about this statement? This statement, we cannot guarantee for each run how many times it will be executed, because if the condition is satisfied all the times, it will be n minus 1. The condition is not satisfied for all the I, it will be 0. When it happens is, when condition does not satisfy is the first element itself is a big number. Like in this array, suppose I modify this to 40, then this statement will not execute. But this statement will anyway check and it will execute n minus 1 times. So, but if the input is like say 10, 15, 20, 25, 30, then all the times this max assigned to A will be executed. So this is dependent on the input. Why it is dependent on the input is condition has the value AI, that is a input value. So you cannot exactly say how many times it will be executed. For the time being we take it the worst case, like in the worst case it will execute n minus 1 times. So this will be C4 into n minus 1 time. I put C1, C2, C3, C4 because each statement we assume different running time. So what are the values of C1, C2, C3, C4, which is highest, we are not bothered now. Why this is n is when there will be a last statement where it checks whether I is greater than n minus 1. That is also included in. I equal to 1 to n minus 1, the condition is satisfied. When I becomes n, it will check whether I is less than n minus 1. That is also included here. So the total running time will be C1 plus C2 into n plus C3 into n minus 1 plus C4 into n minus 1. This C4 into n minus 1 is depending on the input. In the worst case, this will be the value. So, you can say that if the input size is n, then the running time can be taken, this is n. So, if you identify, so the running time can be taken as like linear, like if the input size is n, the running time can be less than some C5 into n, where C5 is greater than C1, C2, C3, C4. Then can take like running time will be less than C5 into n. So, this is the way you will be looking at algorithms, like you have some input, you have some output, you write a pseudo code which is independent of any language, then you can implement it in a programming language which is C, or it could be Pascal, it could be C++. Once you have the algorithm, you can straight away convert this to a program, because algorithm is independent of the programming language, then can get an idea about how much time it will take. So, here for the input array A, it is not given like array is sorted or anything. So, you have to assume that the array is not sorted. But some cases, if say array A sorted in ascending order, finding the maximum element is trivial. You do not have to do this loop, you have to take the last element which will be the highest element. So, this is the way you will be looking at algorithms and the running time. So, in the course we will be mainly focusing on the running time, not on the space how much space it takes. But I mean space complexity is not too much bothered, but we will be bothered about time complexity. Okay. So, time complexity, maybe I can give some example here, like suppose you have a function fn and it's like n log 2 to the base n square n cube n square n cube 2 raised to n. So, maybe I will do it for the values of n being 1, 2, 3, 4, then let me make it 10 and 100. So, if for this function, if n is 1, then it is 1, 2, 3, 4, 10, 100. So, so for this like n log n for n log 2 to the base n, it will be 2 for this value. If it is 4, 4 and log 2 to the base 4 is 2. So, it will be 4 into 2, that will be 8. Similarly, this will increase. Suppose if it is n square, the value will be 1, 4, then 9, 16, 100, this will become 10 to the power 4. If it is n cube, it will be 1, 2 raised to 8, 27, so it will keep on increasing. So, it will be like 3 raised to 4, 3 raised to 10, 3 raised to 100. If it is 2 raised to n, the time will be like 1, it will be 2, it will be 4, 8, this will be 16, this will be 2 raised to, sorry, this is not, this is wrong, you might have noted it. This is n is 27, so when n is 4, it's 4 raised to 3. So this is 1. This is n is 2 means 2 raised to 3, it's 8. 3 means 3 raised to 3, it's 27. It's 27 into 3, it is 81. Then it will be, this will be n is 10, it will be 10 cube. So 10 cube, it will be, or 10 cube means 1000. This will be 10 raised to, sorry, 1000, 100 raised to 3. That will be like 10 raised to 6. So if you look at 2 raised to n, 2 raised to n, it will be like, here it will be 1024. And this will be, so even higher value, so 2 raised to like 2 raised to 100. So here what I want to emphasize is, if you look at this value, after some times the 2 raised to n is the highest time consuming, highest value, having highest value. So complexity is like 2 raised to n, then look at value of 10, it will be like 1024, then it beats n cube. 1024 and 1000. Here is 2 raised to 100 and 10 raised to 6. So this is like 10 raised to 6 is like 1000 into 1000, but 2 raised to 100 is even greater than this value. So you can find that whenever n finds at the exponential part, n exponent, then running time will be high. So you have to find algorithms where it is very efficient in terms of running time, and also space required is very minimal. We will be seeing so many algorithms and looking at the complexity and how efficient it is, and also we will be looking at so many data structures. I mentioned queue, there will be stack, there will be heap, there will be binary trees, many more. Stack also you might have seen in some examples, and even queue I mentioned with respect to only a booking station where you have to stand at the back of the queue. Even queue is, you might have seen, or the word queue in, even in a computer itself, like say it's printer queue, like when you print a document, it will be like the printer will take it one by one. The document is given first, it will be printed first. So it has application with respect to this printer utility. And so stack also we will see what are the real life examples where it is required, and also the not real life, the real life means computer science perspective, what is the requirement of stack, what is the requirement of heap, those things we will see along with studying the data structure. For implementation of this, you will require structures, pointers, etc. Okay. So that's all for this initial lecture. Maybe next lecture I will discuss about what type of computer we will be looking at for the study, because that we will study in the next part of the lecture. Okay, that's all. Thank you.